Okay guys, let's take a look for a second at some graphing tips for translations of the sine and cosine curves and some quick observations we can make if you like a formula approach. One thing that we've already noticed is the following. If you are graphing, you can see on my screen the green graph is cosine of x and the red graph is sine of x. Let's say I take cosine of x and I want to graph twice cosine of x. Since I'm multiplying the y coordinates by 2, the values where cosine is, oops, that's a little off scale there. The values where cosine is 1 would become y values where cosine is 2. For example, the point 0, 1 here would be vertically stretched and become the point 0, 2. Likewise, the point pi negative 1 would become the ordered pair pi negative 2. Actually, I'll put that in the way there. Sorry about that. So here we have the value negative 1, and here we have to scale the value negative 2. Okay, so this would become pi negative 2. And this is what we call a vertical stretch of the graph. If the y coordinate is already 0, 0 times 2 is still 0, and 1 times 2 is 1, and we'd have a vertically stretched graph. You can notice in this graph that because your highs and lows are directly affected by the vertical stretch or compression, so the bottom line is that if you have a basic sine or cosine curve, the vertical stretch or compression is an indicator of the amplitude. So let us say it this way. The amplitude is a positive number measuring the total height of the graph divided by 2. Okay, so it's measuring really this part here or here, take your pick, and is the absolute value of the vertical stretch compression. Now the period, in order for you to discover this, this is set up in the theorem in the book, bx plus c, but you could do bx plus or minus c. If there's a plus here, the shift is to the left. If there's a minus, the shift is to the right, and that's consistent with horizontal shifting. The way to keep this simple is you're going to begin a cycle when the argument of your function, and I'll just do plus c here, is equivalent to 0. And you're going to end a cycle when the argument of your function is equivalent to 2 pi. Okay, so if I solve these out with algebra for x, then I know where I start and I end my new cycle. So basically, what this tells me is how to calculate the period. So if I look at the distance between negative c over b in this case and negative c over b plus 2 pi over b, then the period is where you end minus where you begin, and that cleans up to the formula listed in the theorem. Okay, even if I'd use the minus, which is the shift to the right, what would change if this were minus would be this would be plus, okay? And if this were minus, this would be plus. And if that were true, you'd still get the same result. I hope that makes sense. Okay, so now as far as your phase shift is where you begin after you've done the horizontal shifting and horizontal stretching and compressing. So your phase shift for either sine or cosine is determined by making the substitution. Instead of x equals 0 being the beginning point, bx plus or minus c is the beginning point, and if you solve either one of those for x, you get the fact that you could have shifted left or you could have been shifting right depending on the plus or minus in the original, and so your phase shift would be one direction or the other. Okay, so for example, if you are the bx plus c, you're thinking left because of the plus, so your phase shift is negative c over b. But if you're bx minus c, you're thinking right, so your phase shift is positive c over b. Now we want to make sure the net effect of this is that the negative really means negative and the positive really means positive. So I will accentuate that by using the absolute values there. Okay? All right, we'll do another example, one more, to try to deal with this phase shift issue. But the bottom line is, and let's scroll back, the amplitude of sine or cosine, because they do hit highs and lows, is tied to the vertical stretch compression. It is also max minus min divided by 2 in scenarios where you don't see a formula. The period of sine and the period of cosine is originally 2 pi. And what we've discovered is that the period is the absolute value of 2 pi over b, or just simply 2 pi over the absolute value of b if I look at it in general. So if you like a formula, that's great. And if you have minus and you're going left, your phase shift is to the left. If you have plus and you're going right, your phase shift is to the right. Okay, we'll do another video.